We live in a time when you're quite likely to hear people say that science has done away with the need for God, and that atheism is for the intellectual, and science has shown that there really is no need for religion. Now, as a scientist, that is kind of offensive to me, and I'm hoping tonight to show that there really isn't any problem with science and religion coexisting. And it's commonly said on top of that the sort of champions of science and religion are creation and evolution when it comes to the debate between them, and that the intellectual should choose evolution over creation. And so we're going to explore creation and evolution and see what the science says about them and then what the Bible says about them. So here's how we're going to do it. We're going to start with some definitions. So we're going to think about what creation is, what evolution is, and make sure they're all on the same page there. We'll then move on to think about creation, think about some evidence for creation. We'll then go on to think about evolution and some evidence for evolution. We'll then go on to think about what the Bible says about all of this, and then we'll summarize at the end. So, definitions. What is a creationist? So what is it we're talking about when we're thinking of creationism? So this is the idea that an intelligent being brought everything into existence. The entirety of the universe, all the objects, matter therein, were brought into existence by an intelligent being. And on top of that, all of the laws of that universe were brought into existence by an intelligent being. So they're not random laws. The fact that water boils at 100 degrees, or that the Earth orbits the Sun, or that you can use hyperpolarized xenon gas to image the human respiratory system, these are all laws that have been given to us by an intelligent creator and not by random chance. And then that leads on to the idea that if we have an intelligent creator of everything, that creator probably has some purpose with their creation. They probably haven't done it for no reason. As a final additional point, a creationist would say that life comes into the category of things that were made specifically by this intelligent creator. Life didn't just appear by chance. So that is a very quick summary of creationism. The more complex question is, what's evolution? I'm sure you're all aware that it was first introduced by Charles Darwin as an explanation for the diversity of life we see around us, and that was in about 1859. The theory has been developed extensively since its original proposal, and I'm going to try and explain to you how it works. So, we start off with this first statement on the slide. Life forms reproduce and therefore have a tendency to become more numerous. That's fairly obvious. If I have 2 giraffes, then after a period of time I'll have more giraffes, and that will carry on as time goes on. But then the second point comes in, which is factors such as predation and competition work against this. So I won't get an infinite amount of giraffes because they'll run out of food, or lions will eat some of them, or something like that. So I'll get a certain amount of giraffes. Then we get the third point coming in. So the babies of a giraffe are not the same as its parents. You don't get an identical copy every time you get a new generation. There's a bit of variation, which is called a mutation, that happens between the parents and the offspring. And then these differences, they can be small, they can be a bit larger. If they're beneficial, then the offspring is more likely to survive. So if I have my 2 giraffes and they give birth to a giraffe with slightly better eyesight, then that giraffe is more likely to survive than a giraffe with less good eyesight. And then that builds up over time. This is the idea coming along. The more good mutations you have, the more likely you are to survive, and the more likely you are to pass on your mutations to the next generation. If your mutations are bad, then they will die out. And this gives the idea that you get variation within populations. So if I have my original giraffes, and some of them have got longer necks, then they are likely to become more populous near tall trees. And so you start getting variety within populations. And this is categorized as, this is called microevolution. That's the term for it. And this is variety within a species. And we can look at examples of that. So you can look at dogs. A Great Dane and a Chihuahua are both types of dog, but they look very different. So that's variety within a species. And then the final point of evolution is that final point on the slide there. This is where we make a large assumption. The idea is that over time, these populations, with their changes, split off into different species. So you no longer have a dog, you have a different animal, you have a cat or something. So the idea with that might be that you have something that's like a mule, and over time you get half of the population is more like horses, half is more like donkeys, you end up with donkeys and horses. That's an example that's not supported by evolutionists, it's just a demonstration. Now, that's where we start to have a little bit of, this is called macroevolution, I should say, this variation of species. And that's where we have a large assumption. So that's where we're going to focus most of our thoughts on, because all the first statements, the first 6, they're all verifiable. They've all been shown to work in labs. But this final point, that populations can split into new species, that's where we have difficulties. So we'll come to that later. For now, we'll go back to creation. And we're going to try and see whether there's any evidence to show that creation has happened. And the thing we're going to look at is the origin of life itself. Now, to look at this, we're going to consider one of the basic building blocks of life, and that is enzymes. So every single cell in your body contains these little things called enzymes. And an enzyme is a protein, which is one of these. It's a chain made up of amino acid links held together by what's called peptide bonds. Now, there are 20 different kinds of amino acid in life. Now, the different types of amino acid you can get in a chain will affect the structure and the function of the protein. So it's kind of like letters in a word. The letters make up the words, and that gives it its function. Similarly, the ordering of the amino acids has an effect. So these two proteins, they have the same building blocks, but in a different order, and therefore they would be different proteins. So that, again, works like letters. Tablet and battle, they have the same letters, but they have very different meanings because they're in a different order. Now, protein structure varies wildly. It goes from simple chains to complex 3D shapes. And enzymes are one of the complex 3D shapes that you can get as proteins. Now, that's what an enzyme is, but what does an enzyme do? What's its function? An enzyme acts as a catalyst. So the respiration is a fairly well-known process that occurs in life. And it's given by glucose plus oxygen gives you carbon dioxide plus water. But if I were to get a little beaker over here and pour in some glucose, there's oxygen in the air, it's not going to fizz away and produce carbon dioxide and water, because it doesn't have the necessary conditions. It doesn't have a catalyst to speed up the reaction. Now, I choose respiration here because this is a process that happens in all of your cells, and it requires enzymes to make it happen in your cells. So I'm proving to you that you need to have enzymes to have life. That's vitally important. Because now that we know that we need enzymes, and we know what they're made of, we can consider how likely it is for an enzyme to form by chance. So let's imagine that we have a pool, a primordial pool of ooze, and it contains all types of amino acid. And to make the math simple, we're going to say that it has an infinite amount of every type of amino acid, all 20 types, and we're going to say that all amino acids are equally likely to bond together. Now, that's not true, but it stacks everything sort of in favor of things forming by chance the way you want. Now, if I should tell you about lysozyme first. This is lysozyme. Lysozyme is one of the smallest enzymes. So it has a chain length of 129 at the shortest. It's one of the shortest enzymes you get in life, and it occurs in almost every single cell in your body. Now, we're going to consider how likely it is to form one of these by chance. So we go back to our pool. If I take one amino acid out of that pool, I have 20 possible amino acids I could pull out. So if I want to get a specific protein with a length of 1, then I've got a 1 in 20 chance of getting the right protein just by reaching into the pool and pulling out a random one. If I want a chain length of 2, so this is a protein with 2 amino acids making it up, then there's 20 possible amino acids for the first and 20 possible amino acids for the second in the chain, which means there are 400 possible proteins with a chain length of 2. I can scale that up if I have a chain length of 3, then it's 20 times 20 times 20, so 20 to the power of 3. That gives you 8,000 possible proteins with a chain length of 3. Now, I just told you that lysozyme has 129 amino acids. So, I want any working one. I'm not picky about what kind of lysozyme I have, and I will tell you that there are 10 million working combinations of lysozyme. So I want any of those 10 million. If I do the maths, I get 1 in 20 to the power of 129, which gives you a probability of 1 in 6.8 times 10 to the 167. That's your odds of getting a specific protein with a chain length of 129. I carry through my 10 million, and the probability of getting any working lysozyme is 1 in 10 to the 160. To put that in context, that's 10 to the 160 written out. This is the probability of forming the smallest enzyme by chance. That's a really, really, really big number, and therefore a really small probability. It's such a big number that it's very hard to wrap your head around how big that number is. So I thought of a few things to put it in context. It's been proposed that there are 10 to the 80 subatomic particles in the universe. So if I were to ask someone to point at a random atom anywhere in the universe, they're more likely to get that right than they are for lysozyme to form by chance in this way. The closest approximation of something this unlikely I could find is you're more likely to win the lottery 38 times consecutively. And this is assuming ideal conditions for proteins to form. Now, that's really unlikely, but then the common answer to this is for people to say, but there are loads of planets and the universe is like really old, so that's going to happen eventually. But we can look at that in a bit more detail, because the universe isn't as big or old as people might expect. So it's estimated that there are less than 10 to the 30 planets in the entire universe. So if you assume that all of those planets have all of the necessary elements to make proteins and have been creating one protein every single second since the oldest estimate of the universe, which is about 10 to the 17 seconds ago, you get about 10 to the 50 combinations. So it's unlikely that any of them are going to be a single working lysozyme. You can't just cancel big numbers. So the numbers 10 to the 160 and 10 to the 50 sound quite similar, but I'm going to try and show you that they're very different. So if you were to count to 100, which is 10 to the power of 2, it would take you about 30 seconds. So if you want 1, 2, 3, 4, 25 to 35 seconds. If you counted to 1,000, it would take you about 5 minutes. That's 10 to the 3. 10 to the 4, it would take you an hour. 10 to the 6 would take you 2 weeks. And 10 to the 9 would take you 50 years. So you can see how the power on the far left, as you're looking at it, increases much slower than the time it would take to count to that, which gives you an idea of how big these numbers are that we're talking about. So it's very unlikely to form any enzyme by chance. Now let's think more about how much we need these enzymes. And we're going to think about respiration in a bit more detail. I'm going to think about how you break down glucose in your body. So this is the process of glucose metabolism. Glucose comes in there at the top. It undergoes glycolysis. That produces some ATP and some NADH. Now, ATP is the energy of your body, basically. This is how your cells keep energy. So think of ATP as energy. NADH, that's toxic, so you don't want to keep that around. The glycolysis produces pyruvate. That gets converted in a series of reactions that gives you 2 carbon dioxides and more toxic NADH. The pyruvate is converted into acetyl coenzyme A, which then goes into the citric acid cycle, or the Krebs cycle, where it undergoes a series of reactions that produces 4 carbon dioxide, 2 ATP, so more energy, and more toxic NADH. So you can see where your carbon dioxide comes from in the equation. And then all of these NADHs, they go through what's called the electron transport chain, and that produces the water and the remaining energy, so 28 ATP. That's the majority of your energy, and that deals with the toxic side of this. So you can see that it's very important that you have all these steps at once. If you have the first step, just glycolysis, then your cells will build up a large amount of toxic NADH and you will die. And that's true for all of those steps unless you do have the electron transport chain, which requires all of those NADHs to work. So you need all of this at once Otherwise, it doesn't work. And we can go a step further in the complexity of this by looking at glycolysis. This is the process of glycolysis. It's complicated. Glucose comes in, and it goes through all of those steps and comes out as pyruvate. Now, there's a few things I want to point out here. Firstly, you can see in the first step that ATP is used to do the first step. So ATP turns into ADP. So you've lost energy from the system. You go down to step 3 there, and again, you've lost energy in the system. And that energy comes back much later on. So once again, you need all of those steps in place for the process to work. Otherwise, it would be losing energy instead of gaining energy. And that wouldn't be beneficial. On top of this, every single one of those dark blue arrows requires at least one enzyme to work. So if we're thinking about the probability of forming life just completely by chance, think about how unlikely it was to form a single enzyme, and now scale that up to forming all of those enzymes. And remember that the enzyme we thought about before, lysozyme, is the simplest enzyme. These are much more complicated. And we can carry on. There's the citric acid cycle. It's also very complicated. And again, it's another cycle. You need to have all of these steps in place, otherwise it doesn't work. And again, it needs a whole load of enzymes, otherwise it doesn't work. The odds of this happening by chance is ridiculously small. So you have all this evidence now starting to stack up that you are so incredibly complicatedly made that it seems impossible for you to have come about by chance. Now, we've thought about how unlikely it is to form enzymes, and sadly, I don't have enough time to go into the details of how we do make enzymes in our body, because we have DNA. DNA is how we make these complicated micro machines. And DNA is a digital code in every single cell of your body. It's base 4, and it's self-replicating, and it's self-repairing. It's incredible that we have this information stored in our cells. The idea of information I find to be very indicative of design. Now, has anyone ever heard of SETI? The Search for Extraterrestrial Intelligence, it's called. This is some people who, they listen out for radio signals from space, and they're trying to identify whether there's any sign of intelligence anywhere in the universe. Now, the thing that they're looking for is this. Series of pulses counting up from 1 to 6. If they see a series of pulses on a screen that count from 1 to 6, then they say, that's not chance, that's not random, that is intelligence. And I put it to you, is that more intelligent seeming than all of these complicated systems that we've seen, which are all guided by a digital code? We are fearfully and wonderfully made. So that was a quick look at just some of the evidence there is for creationism. We'll now turn and look to see what we can say about evolution. So we're dealing now with the origin of species. The most quoted piece of evidence for evolution is that of the fossil record. So a fossil is the petrified remains of an organism that died a long time ago and has been preserved in rock. So I have some here. These are fossils. This is an ammonite, and this is a trilobite. And the interesting thing about this is that I can tell you that that's an ammonite, and I can tell you that's a trilobite. So you get certain fossils that appear with such a large frequency that no one will dispute what they are. So everyone will tell you that's an ammonite. Who knows about fossils? Everyone will tell you that's a trilobite. Put them over there. The reason that's interesting is that the process of evolution follows a large amount of very small steps, which are wide-ranging. You shouldn't expect to find specific organisms coming up over and over again, unless you had so many fossils that I could walk into any museum and see before me an entire array of the entire evolution of life laid out in fossils. This is the geological record. This is a timeline of the geological ages that we have, and their proposed dates that they are given. So they go from now at the far right to about 500 million years ago and a bit before. And what's interesting about this, we have all these different ages. We have Cambrian period, we have Silurian, and so on. The big numbers that are marked on, these are extinction events. This is where 60 to 90% of all life on the planet is wiped out. The most well-known of these is marked on there as 1. That's the KT extinction event. That's the end of dinosaurs and the start of life that is more well-known. And the interesting thing about this is that when you have 60 to 90% of life disappearing all at once, you would expect to find a slow build-up of life happening again. So if I go back to my population of giraffes, if 90% of those giraffes died, I'd expect it to be a really long time before I had a large population of giraffes again. But that's not what you find. You suddenly get a large explosion of life immediately after these extinction events. You get a sort of creation event immediately afterwards. And it's all new types of life. You get a sudden change in the style of life. And that's very interesting. But what's more interesting is those letters that are marked on. Because these represent events known as radiations or explosions. And this is where you get a sudden change in life without the extinction event. There's just suddenly more life. It just pops up really quickly. The most well-known of these is marked with letter A. You get the Cambrian explosion. And that's where you go from, the fossil record before this has just single-celled organisms and some soft-bodied worms. And then after the Cambrian explosion, you suddenly get all sorts of interesting life forms. So you get the trilobite and so on. You get all of the phylums that you get today. So a phylum is the subgroup of organisms below kingdom. So we are, as humans, we are of the animal kingdom. We're of the vertebrate phylum, because we've got backbone vertebrates. That phylum appears in the Cambrian times. Before then, doesn't appear at all. So you get this sudden explosion in complexity. And that doesn't match the evolutionary model. From the evolutionary model, you'd expect things to slowly build up in complexity. You'd expect there to be lots of dead ends, where something sort of had a mutation that started to work but then didn't go anywhere. You'd expect to see all these fossils around. And the common answer that people give to why you don't see all these fossils is, fossils don't form uniformly. They don't form. You need specific conditions for a fossil to form. And so that's why you get certain types of fossil appearing and not others. But then that's really just saying why there isn't why the fossil record doesn't back up evolution. That's not saying why it does. So if you assume that evolution is true, then you might be able to say that the lack of fossil evidence comes from fossils not forming at the right time, but it doesn't work the other way around. But is that the only evidence the fossil record provided to support the theory of evolution? Well, there is some experimental evidence. There's an experiment that's been running since 1988, and it's been tracking genetic changes in populations of E. coli over many generations. It's called the long-term evolutionary E. coli experiment. Yes. And in 2014, they reached their 60,000th generation of E. coli. That's a lot of generations, 60,000. And there are 12 populations of E. coli. They were kept in different environments to see how they will react to their environment. And one of those populations has undergone a large mutation, and it can now process citrate, which it couldn't do before. Now, that's really several mutations. Some say it's as low as 2, but some say it's as high as 5. So this is important for you to remember, 5 mutations in 60,000 generations. Because with that figure, we can do some maths. The animal with the most DNA in common with humans is the chimpanzee. So if humans and chimpanzees, with two species like humans and chimpanzees, the theory of evolution would say that we come from a common ancestor that's somewhere in between the two, and it splits into 2 species. One becomes humans, one becomes chimpanzees. So we can think about this common ancestor and assume that it's exactly halfway between the 2 species, genetically speaking. And then by multiplying multiplying the time for a generation by the number of genetic differences and dividing it by the rate of mutation, we can calculate the time it takes to get from one species to another, or from a common ancestor to a new species. So we can fill in some of these numbers. So the first question, what's the time for a generation? For humans, for a generation is how long does it take for your offspring to reach sexual maturity and have more offspring. For humans, it's about 15 years. For chimpanzees, it's closer to 10. So we'll go with 10 to put everything in favor of evolution. And we'll assume that the common ancestor is 10. That also makes the maths easier. We know the genetic differences. So it's said that we are 98% similar to a chimpanzee, which sounds like we're very similar, except that you have a lot of DNA. So that's actually 40 million genetic differences. So that's a combination of added genetic information, deleted genetic information, and substituted genetic information. So we've got 40 million differences. So what about the rate? If we remember our long-term evolutionary experiment, we had 60,000 generations which developed 5 mutations. So if we stack things a little in favor of evolution, that's 1 mutation every 10,000 generations. So that's a rate of 0.0001 mutations per generation. And we've divided it all by 2 because we're assuming that the common ancestor is halfway between the two. We plug in all the numbers, and we get that it would take 2,000 billion years to get from something that is halfway between a chimpanzee and a human to either a chimpanzee or a human. That is that's a long time. The oldest estimates of the age of the universe put it at 14 billion years old. So we're quite off there. And this is getting from, as I say, something halfway between a chimpanzee and a human to a human. Imagine how long it would take to get from a single-celled organism to a carrot. But we have been a little unfair because you can't just directly take the rate of mutation between bacteria and humans. So, to stack absolutely everything in favor of evolution, we're going to assume that every generation we have an advantageous mutation, and that mutation is somehow immediately passed throughout the entire generation. So every generation has a new advantageous mutation, which is completely impossible, but we'll roll with it. That gives us a rate of 1 instead of 0.0001, and we get instead 200 million years for our time. If I just quickly go back to our timeline there, 200 million years puts us right at the start of the Jurassic period. That's when dinosaurs are, and the commonly quoted time for the ancestor of man and chimp is given as 5 to 7 million years ago. So we're off again, we're way off. This process needs to take a lot shorter than it should do by any maths. Now this maths problem is not new. I'm not the first person to present this. It's got a fancy name. It's called Haldane's dilemma, and I recommend you all look it up and read more about the intricacies of it, because it's quite an interesting little problem. So far we've seen that the fossil record doesn't support evolution as it is said to, and we've seen that the maths doesn't support evolution as it's said to. So rather than trying to see whether there's any more evidence to support evolution, because I'm running out, I'm instead going to consider whether evolution can account for everything that occurs around us. So the question is, can the process of having simple, small changes building up over time, as proposed by the theory of evolution, give you the circulatory system? So, a circulatory system requires certain things. It requires blood. It requires a series of tubes that carry the blood through the body, so blood vessels. It requires a pump, and that is the heart, and that pump needs to have a muscle to pump the blood. It needs to have a valve to direct flow. If it just pumped, then all of the blood would end up at the opposite side of your body to your heart, where it isn't very helpful. And it needs a pacemaker, because it needs to be regularly pumping the blood. On top of this, overall, you need waste removal. For that, you have the kidneys, and they prevent the buildup of waste in the blood, which would be toxic. You need a source of oxygen and nutrients for the blood, so you have the lungs and digestive system for that. And they themselves are also extremely complicated systems. They need lots of parts, and we could look at them in more detail, but we're not going to. And finally, you need a repair mechanism. If you don't have a repair mechanism, then if you've got a small cut, you would die. That would be bad. And you need all of these component parts all at once. It can't be done by slowly adding them one at a time. If you have a series of tubes but no blood, then that doesn't work. If you have a pump but no tubes, that doesn't work. If you have a pump and blood and tubes but you don't have any way of getting oxygen and nutrients into your body, then that doesn't work. You need to have all of these things simultaneously. And that's something that doesn't agree with the theory of evolution. So here's my summary on what we've thought about on evolution. The most commonly given evidence for the theory of evolution is the fossil record. However, the large jumps we get in complexity, which are called either explosions or radiations, don't fit this model. So the fossil record doesn't really go with the theory, and we've got the example of the Cambrian explosion for that. If we ignore that and just stick to the theory anyway and do some maths to investigate the rate at which mutations can happen and the timescales that evolutionists propose, we find that these don't match each other. Any feasible rate at which mutation can occur is too slow for the timescales provided, so the theory breaks down again. And if we ignore both of those, we still have the problem that evolution doesn't explain large-scale systems, such as the circulatory system. The origin of systems gives the origin of species some difficulty. And so now this brings us to our final section on what the Bible teaches about all this. So far, you may have noticed we haven't actually mentioned the Bible, aside from the reading that we had at the start. And this highlights my original point, that there isn't this rift between science and religion that comes to a point at the creation-evolution debate. So far, we've seen that the science has been supporting creation, not evolution. But now, this is a Bible talk, so we're going to think a bit about what the Bible says about all this. Now, there's a movement that suggests that evolution occurs and is aided by God. And these are theistic evolutionists, so that's the people who suggest this. And there are two types of theistic evolution. One is to say that God created life, so you've overcome the difficulty of the origin of life, but then once he'd created a single-celled organism, he let it develop in its own way, and it just evolved into all the variety of life we have today. Now that immediately gives the problem that all of the difficulties we have in this summary apply to that theory. There's issues that it doesn't answer. So then we have the other type of theistic evolution, which is to say that every time a difficulty arises, God gives evolution a little nudge. So all of these radiations, that's when God just gives evolution a big nudge and it moves along. These large-scale systems are God's giving it a nudge to help it go, and all of the difficulties with timescales, God's just sped the process up a bit. Really the problem with that is by the time you've accounted for every problem there is that we've looked at, you've not really got evolution anymore, you've just got a series of creation events one after another. But really, it doesn't go with the Bible, and we'll come to that in a moment. Now, there are a lot of related issues to this topic that we haven't covered. So I haven't looked at the age of the Earth, because that's really a topic in its own right, which is open to some discussion. So if you want to talk about that with me afterwards, you can. But now we'll think about these things in context of the Bible. So it might not be a surprise to you to hear that the Bible says that God created everything, and it says this on multiple occasions. So here's a non-exhaustive list of all the verses of creation. So you've got Genesis 1 and 2 there, with the creation account. You've got Deuteronomy, God created man upon the earth. Isaiah, he who created the heavens, I, Jehovah, have created it. Has not one God created us? Since the beginning of the creation which God created, all things were created through him and for him. You created all things, and for your will they were created. And that's just, as I say, a sampling of the verses that talk about creation. But notice on this list we go from the very start of the Bible to the last book of the Bible, Revelation. And partway through there we had in Mark a quote from the Lord Jesus himself, and he clearly accepts creation. So what about evolution? What does the Bible say about this? In short, not a lot, but there is a little bit we can look at. So we're going to go to Genesis chapter 1. I put the slides on the screen, but they're probably not very visible. So we have here Genesis chapter 1, and we're going to start reading at verse 11. Then God said, "Let the earth bring forth grass, that herb that yields seed, and the fruit tree that yields fruit according to its kind, whose seed is in itself on the earth." And it was so. And the earth brought forth grass, the herb that yields seed according to its kind, and the tree that yields fruit, whose seed is in itself according to its kind. And God saw that it was good. So the evening and the morning were the third day. So this is talking about God creating the plants. And you may have noticed a phrase coming through time and time again there, that the plants were yielding seeds after their own kind. And that seems to refer to the way in which if you collect seeds from a peach tree and plant them, then you will get more peach trees. You can get different types of peach trees, but if you wanted a pear tree, you're out of luck because you're going to get a peach tree. And that's the difference between microevolution and macroevolution coming through. And it's not just the plants that this applies to. If we go to verse 20, then there we go. Then God said, "Let the waters abound with an abundance of living creatures, and let the birds fly above the earth across the face of the firmament of the heavens." So God created the great sea creatures and every living thing that moves, with which the waters abounded, according to their kind, and every winged bird according to its kind. And God saw that it was good. And God blessed them, saying, "Be fruitful and multiply, and fill the waters of the sea, and let the birds multiply on the earth." So the evening and the morning were the fifth day. Then God said, "Let the earth bring forth the living creature according to its kind, cattle and creeping thing and beast of the earth, each according to its kind." And it was so. And God made the beast of the earth according to its kind, cattle according to its kind, and everything that creeps on the earth according to its kind. And God saw that everything was good. So again, all the animals are created after their own kind. Notice that the aquatic animals and the birds are created on a different day to land animals. That doesn't fit with the theory of evolution or theistic evolution. These appear to be separate creation events, as it were. Now, I'm not going to go into the details of the length of each day, because again, that's a topic in its own right. But I will also happily talk about that with you afterwards, if you want to. But I did deliberately stop just then reading about the sixth day of creation for a reason. And that's because we're about to consider the origin of man. Now, if we accept evolution, then there's nothing particularly special about man. We're just a slightly smarter ape than average, and that would be brought about by random chance and being better suited to our environment. This is true whether you accept atheistic or just theistic evolution. So what does the Bible say on the matter of the origin of man? Verse 26 of Genesis chapter 1. Then God said, "Let us make man in our own image, according to our own likeness, and let them have dominion over the fish of the sea, over the birds of the air, and over the cattle, over all the earth, and over every creeping thing that creeps on the earth." So God created man in his own image. In the image of God created he him, male and female he created them. Then God blessed them and said to them, "Be fruitful and multiply, fill the earth and subdue it. Have dominion over the fish of the sea, over the birds of the air, and over every living thing that moves on the earth." And God said, "See, I have given you every herb that yields seed, which is on the face of the earth, and every tree whose fruit yields seed. To you it shall be for food." And it goes on. And it finishes with, "Then God saw everything that he had made, and indeed it was very good. And the evening and the morning were the sixth day." Does that read like there was nothing special about man's origin? No. It's very clear that man has been given special treatment over the other animals. Now, can we say that this is just a point in human evolution where man became smart enough that God thought it was time to make him in his image? It doesn't really make sense. And anyway, in Genesis chapter 2, it says that God formed man out of the dust of the ground. So man is special. And if you're of the opinion that you can just ignore Genesis chapter 1 or all of Genesis or all of the Old Testament maybe, then look at Mark chapter 10. It's on the screen. This is a quote from Jesus. It says, "But from the beginning of the creation, God made them male and female." Jesus accepts that this is how man came to be. So the Bible most definitely supports creation and not evolution. But it also makes one thing clear on top of all this, which is that we don't know the exact details of how creation happened. We're just not told it. And that's probably because we just wouldn't understand. Only God knows about these things. We wouldn't understand it even if it was told to us. So let's sum up what we've said this evening. So we started off with our definitions. We defined creation as being the idea that everything was created by an intelligent designer with a specific purpose in mind. Then we went on to think about how evolution says that all of the variety of different species of life comes from small random changes that cause organisms to become better adapted to their environments, which is fine, but then it goes on to make a large extrapolating assumption that this can cause new species to form from old species. Then we went on from this to think about creation. We thought about how it would be impossibly hard to form a single enzyme by chance. and then we saw how many of those we would need for life to exist in its current complexity, and how that requires you to therefore have a creator. We then moved on to think about evolution, and noted that creation events such as the Cambrian explosion mean that the fossil record doesn't match the model of evolution. And on top of that, when you think about the timescales in mutating from a half-chimp, half-man to a man or chimp, we realized that the timescales don't add up. And then we looked at how the lack of supporting evidence isn't the only problem for evolution, but also that the theory cannot explain fundamental things such as the circulatory system. And just now we thought about what the Bible has to say about all this, and perhaps unsurprisingly, we found that it heavily supports the idea of creation, but doesn't have much to say about evolution. And we very briefly in that considered the idea of theistic evolution and how it gives rise to some issues about the significance of man, as well as not really answering any of the issues faced with the theory of evolution. Thank you for listening.
BibleTruthAndProphecy.com is a worldwide collaboration by Christadelphians to help promote the understanding of God's Word to those who are seeking the truth about the human condition and God's plan and purpose with this earth and with mankind upon it. Bible Truth and Prophecy is part of a wider set of online resources provided by Christadelphianvideo.org for establishing just how far removed the true Christian teaching of the first century apostles is from that taught by mainstream Christendom today. BibleTruthAndProphecy.com is very much a standalone website, but benefits from our vast network of sites and resources and social media. Here are just a few of the things that BibleTruthAndProphecy.com offers. We have a good number of written articles supplied to us from brothers from all over the globe. These deal with first principle issues, creation versus evolution, the inspiration of the Bible, and so much more. We have a whole section of video study series. These are studies that have been posted onto our YouTube channel, but because of the difficulty of the search feature within YouTube, we have chosen to host on Bible Truth and Prophecy. So now every video you search for within the site, you can be guaranteed that it will be of a Christadelphian nature. We also have a preaching video section where any ecclesia is invited to download and use or embed these videos within their own ecclesial websites. We also have an exhortation service where we produce 2 or 3 exhortations per week, which we then circulate to brethren and sisters in isolation. We also have an ever-growing list of approved Christadelphian sites. We also have a page of live news feeds, so you can keep up to date with all the breaking news as it happens. We also have a section for the daily readings. Each day at around midnight we publish all 3 of the daily readings, and then later on in the day we publish thought for the days, often based on all 3 portions of the daily readings. Within each daily reading post there is also a link to enable you to have the Bible chapter read to you directly. We also feature Bible in the News videos which we have produced from the Bible in the News website. We also feature Brother Don Pierce's milestone snippets, which come out approximately 3 times a week. We also feature Andy Walton's weekly World Watch, and other commentaries and analysis from other brethren on world news events. You can also subscribe to the blog and be notified of posts as they happen in real time, and also subscribe to the weekly newsletter which is provided by Christadelphianvideo.org. Every page and post on the site has the facility to be able to leave a comment or make an observation, so please take advantage of this and let us know what you think of the site.